Greetings. Welcome to Machine vs Mathematics channel. We have a bridge-based problem asked in GATE ECE 2013 for 2 marks. It is very simple to solve. We can form a bridge out of this. So you have 4 diodes. They are connected like this, and these 4 diodes are ideal. They are ideal diodes. Now he gave this information. A voltage 1000 sine omega t volts is applied across YZ. Say, let me apply like this. Okay, so let me apply AC voltage across this terminals YZ, and this is say 1000 sine omega t. Okay, now assuming assuming these ideal diodes, the voltage measured across WX. Okay, the voltage measured across these 2 terminals he is asking now. It's very simple. Let's take 4 diodes, as let us label them as D1, D2, D3 and D4. Okay, 1000 sine omega t we take for positive time. So you have like this, so on. And this fellow is what? And he is 1000. And this is negative 1000. Okay, and this will repeat like this, say. Now during this positive half cycle, we are applying 1000 sine omega t volts across terminals YZ. So therefore we will try to find out a voltage across WX, right? So during this positive half cycle, what happens? For the positive half cycle, D1 and D2 will remain off. Say for positive half cycle, what happens? D1 for positive half cycle, we can write D1 and D2. Yes or not? Because see, positive, that means cathode are made positive with respect to anode. So therefore D1 and D2, they will become reverse biased. So D1 and D2 reverse biased, or simply we can say D1 and D2 are off. Okay, now for the same positive half cycle, D3 and D4, they are forward biased. Why? For the same positive half cycle, so anodes are made positive with respect to cathode. So therefore D3 and D4 are forward biased, means they are on. And as he gave, these are ideal diodes, so there will be no cut-in voltage for this. So therefore otherwise there is no forward resistance when these 2 quantities are forward biased. So directly we can take this way. So you see, we can redraw that circuit like this. So D1 and D2, they are off. So they are off. So therefore you have Y and you have Z. And now what about this? So you see, D3 is shorted, because they are forward biased, and forward resistance equal to 0 because these are ideal diodes. So therefore D3 and D4 are like this. And across this, what do you have? Across this you have a 1 kilo ohm resistor. So terminals are given like this. All right. Okay, now could you tell me what is voltage across WX now? What is voltage across WX? Now as it is short, now this short is in parallel with this 1 kilo ohm. So whatever current we have, this current will not go through 1 kilo ohm. Otherwise we could say like this. That means there is 0 volt, there is just 0 volt. See this fellow, 0 volt will appear across 1 kilo ohm. So we could say voltage across WX terminals equal to 0. Simple. So for positive half cycle, we obtained voltage across terminals WX is 0. Similarly, we will also go for negative half cycle, and we will check for negative half cycle what happens. This is no big deal. This is a very simple question for 2 marks. Okay, I think we don't require to take more than 10 seconds to solve it, right? Or more than 5 seconds approximately. See, for negative half cycle, if I take negative half cycle, now see, for negative half cycle, what happens now? Now cathode is made negative with respect to anode, means D1 and D2 are forward biased. Now see, for negative half cycle, anode is made negative with respect to cathode, so therefore D3 and D4 are reverse biased. Now in that case, what happens, as D1 and D2 are also ideal diodes, there will be no forward resistance for these two diodes, so that means cut-in voltage we can take it as 0. Otherwise simply we can redraw the circuit like this. So there is no, so okay, so this is D1 ideal, D2 ideal, we can replace by shorts, and these two fellows are out of race now. Now D3 and D4 are reverse biased, yes or not? So I can redraw my circuit like this. You have 1 kilo ohm, okay, whatever. Now this fellow is 1 kilo ohm, so you have YZ. Now what is our interest here? Our interest is finding out voltage across W and X. Okay, terminals WX. Now what do you get? A voltage, this fellow. So he is short, right? He is short, he is in parallel with this fellow. So therefore you get again 0 volts. The voltage across VWX is again 0. That's it. It's very simple, right? Just 2 seconds. Okay. So we can write like this. For negative half cycle, D1 and D2 are on. Okay. And D3, this is D3 and this fellow is D4. D3 and D4 they remain off. Yeah, and in this scenario also, as it is short, see, these two are parallel now. As it is short, so therefore we could say voltage across WX. Voltage across WX is again 0 volts. Now what can we conclude? For both positive cycle, positive half cycle, and for negative half cycle, VWX we obtained 0 volts. So therefore the answer is what? The answer is the voltage measured across WX in volts is 0 for all T. See, if I don't know how to solve this simple question, definitely some of us will go for option B or C, right? Because something is lengthy, and that you have a plus modulus of sign, minus modulus of sign. So we think of going to B or C. Yeah. So please don't do like that. This is a very simple question. First of all, focus on the question what is asking, then accordingly go for it. So option D is correct. So that's it for today. Thank you.